The Puerto Rico Demand Response Impact and Forecast Tool, or PR Drift, is a spreadsheet-based tool developed by NREL in which users can estimate the potential impacts of demand response, energy efficiency, variable renewable energy, and energy storage adoption in Puerto Rico from 2021 to 2040. The purpose of this video is to provide a brief overview of the tool's functionality by using an example scenario based on the 2019 Integrated Resource Plan, or IRP, developed by the Puerto Rico Electric Power Authority, or PREPA. So the first user input here on the PR Drift dashboard is to select a baseline scenario. These baseline load profiles correspond to power demand at each hour of the year from fiscal year or FY 2021 through FY 2040. Users can select low demand, medium demand, or high demand. For this example, we'll select the business as usual or BAU medium demand scenario. In inputs 2 and 3, users can also select a particular fiscal year or a particular month within that fiscal year that they'd like to see more detailed results for in the dashboard. For now, we'll keep it at fiscal year 2040, and we'll look at the month of August in particular. The load profiles shown here in Figure 1 for the residential, commercial, and industrial sector are based on PREPA-provided data from 2016 and 2017 and scaled according to the projections in the IRP. Figure 2 shows the net load profile for each hour on an average day in the selected fiscal year and month, along with projected solar and wind generation based on RFP schedules and Act 17 goals. For input number 4, users can select residential demand response measures by clicking on the link which takes us to the residential tab of PR Drift. Here we can toggle on and off various residential demand response measures. The PREPA 2019 IRP only considers demand response for air conditioning in the residential sector, which corresponds to this first measure of direct control of AC units. In the IRP assumptions, 4.1% of residential customers will be participating in the demand response program by 2040. So that's the value set in column 5, which is another user input column. In column 7, users can set the maximum percent of the participating load that is reduced at any given time. So for this example, we'll leave it at 100%. So we can return to the dashboard and go to input number 5, which prompts users to select commercial demand response measures. This is a pretty similar tab to the residential demand response measures tab. In PREPA's IRP for the commercial sector, the demand response measures considered are for air conditioning and lighting. So we can turn on the demand response measure for HVAC direct control and for lighting controls. The IRP estimates that about 1% of commercial customers will be participating in these demand response programs by 2040. So that's the value that we'll set here in column 5. And then in column 7, for the 2 demand response measures that are turned on, we'll again keep that at 100%. So we'll return to the dashboard and go to user input number 6, which prompts us to select industrial demand response measures. On the industrial tab, there are only 2 user inputs. For input number 1, users can select the total industrial demand response resource available by fiscal year 2040. And this is set to 200 megawatts based on an estimated value from the Puerto Rico Energy Bureau, or PREB. For input number 2, users can select the percent of total industrial demand response resource that's available for emergency deployment only, as opposed to readily available demand response. For this example, we've just set that to 75%, but again, that can be changed. Going back to the dashboard, input number 7 asks users to select an adoption curve for demand response measures. This dictates the incremental adoption levels from 2021 through 2040. So users can select straight line adoption curve, S-curve, or a logarithmic curve. So we'll set that to a straight line adoption curve. Moving on down to input number 8, users can choose whether to incorporate or examine the impact of energy efficiency measures in these load profile projections shown in figure 1 and figure 2. So you can toggle that on or off. In this example, we've set that to on. And if energy efficiency measures are turned on, users can specify the details of these energy efficiency improvements by sector, residential, commercial, industrial, in input number 9. This takes us to the energy efficiency tab. You have a variety of user inputs here, and these user inputs can actually also be based off the results from the Puerto Rico Energy Efficiency Scenario Analysis Tool, or PRESAT, which was also developed by NREL as a precursor to PR Drift. Finally, we have one more user input on the PR Drift dashboard, input number 10. Here, users can set the number of top peak hours in the year that demand response is called for. So we've just set that to 20 for now. So based on all these inputs, various results are visualized at the center of the dashboard. Figures 3, Table 1, Figure 4, Figure 5, Figure 6, and Figure 7. More details are provided in the accompanying slide deck. And then some other important results are displayed in this right-hand bar. You have results 1 all the way down to result 9. So for this scenario, mainly using inputs for PREPA's IRP, we can see that the reduction in peak gross demand that is possible due to readily available demand response resources in the selected fiscal year and month is about 67 megawatts. It should be noted that this represents a feasible technical potential based on user-specified inputs. This is not the economic or market potential. For result 8, we can see that the annual peak net gross demand in the selected fiscal year, if no demand response measures are enacted, is around 1,800 megawatts. However, if we call demand response measures for the top 20 peak hours of the year, again, that was a user input set here, we can see that this reduces the annual peak net gross demand by 30 megawatts. So those are a couple of important results that can have utility planning implications. That was a very brief overview of the PR Drift tool. We encourage you to learn more from the accompanying slide deck, and please reach out if you have any further feedback or questions. Thank you.